So we have a function. We have to express it in this unusual, well, not unusual, different. This is a common question. This form is useful because this is an asymptote. Which could help us find it. Do you know this A is which? Does anyone know which asymptote it is? The x to the y asymptote? Which one? Y is the y, yeah. Why is it the y? Well, we'll come to that afterwards, but it is the y asymptote. Let's see how we find it first, and then we'll explain. Did anyone manage to get it in this form? No. There's a little trick to it. You want to get a number here on its own. Now, both these things are dominated by this division of x minus 1. So that means the only way to get rid of the division of x minus 1 is to have something to cancel it on top. So what you do is you bring x minus 1. You replace that x with x minus 1. Now you've changed the equation by doing that. You've subtracted 2 from the equation, really, by doing that. See that? Because 2 times, no longer 2x minus 3, is 2x minus 2 minus 3. So you've subtracted 2 from the equation. So you need to add 2 to keep it the same equation. That's the trick. Yeah, why I did this? Yeah. You'll see now. It's because now I can split up. So now there's 2 parts to the fraction. There's 2 parts here, but it can't be, nothing can cancel. I want an x minus 1 on top to cancel out the x minus 1 on the bottom. All right, just tidy this up. Minus 3 plus 2 is minus 1. Now I'm going to split this up into 2 fractions. This bit's going to go with the 2, and it's going to go with the minus 1. At this stage, I can do that too. 2x over x minus 1 minus 3 over x minus 1. Problem is that I can't cancel anything out here. If this was 2x minus 1, then I can cancel. But it's just 2x. So I can't cancel. It has to be exactly the same. So that's why that's no good to me. But this will be good. The 2x minus 1 all over x minus 1 minus the 1 over x minus 1. This goes into this perfectly once, which means I'm left with just a constant, which is what I want. There's my A and my B. This then, the A, is the y asymptote. Two. So if you ever ask for this form, and now it'll probably be, you might remember it for Friday, but I have to do it again before the actual final exam next year. Yeah, you want to get rid of this x. You're going to have to make it the same as the denominator to cancel it out. So you just put it in instead, but balance the equation. So remember, I added the 2 here because there's a minus 1 out of nowhere, which of course is really a minus 2. 2 times minus 1 is minus 2. Yeah, so it's a commonly enough asked question. Start. It's good for these rationals, so it's good to know. All right, so that the vertical asymptote and the horizontal asymptote you should be able to do. The vertical asymptote, But what is the vertical asymptote? What's the value for x that it cannot be? 1, yeah. So x is equal to 1, the vertical. You already know the horizontal or the y asymptote, I call it here, the horizontal asymptote. It's this a number, which is 2, which makes sense here with the 2 over 1. Is the horizontal. Okay. Hence, sketch the graph. We've loads of information to sketch the graph, but we don't have enough yet. What else do we need to find? We have 2 asymptotes. We have a general idea of what shape that might look like. What's the other 2 things we need? The roots, yeah. Okay, so I'm going to get rid of this maybe. That's taken down already. So how do I find the roots or where across the x and y axis? So let x equals 0, and you'll find what y is, and then let y equals 0, and you'll find out what the x1 is. So when we let x equal to 0 into this, you can call fx y now. 2 times 0 minus 3 over 0 minus 1. So y then is 0 minus 3 minus 3 minus 1. So it's just 3. So my point there is 0. I inputted 0 and I got out 3. This one, let y equal to 0. So that means 0 equals 2x minus 3 all over x minus 1. When I multiply both sides by x minus 1, that'll just go to 0 anyway. Multiply it up. Add 3 to both sides, and you get x is 3 over 2, I think, to finish. My point then is 3 over 2 and 0. And that's now enough information to draw a graph. Quick sketch. Put in my 1, 2, 3. Put in the points that I know. 0 on x, 3 on y. It's going to be here. 0, 3. 3 over 2 and 0 is going to be here. Okay. Now I also must put in my vertical horizontal asymptotes. There's one at x equal to 1 here. And 1 and y is equal to 2 here. Okay. And now with the these crossing points, you know exactly where to put your graph, and you should know the shape of the graph by now. Something like goes towards the asymptotes, but will never cross it. That type of shape. Okay. Hence sketch. Okay, done that. Part D. Laura, if you're wondering where this question is, it's from Managed back yesterday. Find the domain and range of the inverse. Anyone know this? Do I have to get the inverse? Nope. Why not? Ready? Swapperoo, yeah. So all you need to do is get the range of this one, and it'll be the domain of the inverse. So exactly. So does anyone care to suggest what the domain will be then of the inverse? Maria? Yeah, so you're looking at y. What values does y have here? So there's an asymptote on the y, yeah, here at 2, yeah, that's a blocking point. Yeah, it's going to be greater than 2, but isn't it less than 2 as well, all the way down here? Isn't it going to go to minus infinity and positive infinity? So it's everything except for 2. So x an element of or x cannot be 2. Yeah, everything bar 2. That's how we would suggest it. So that's, remember, that is the range of the original. So it is the domain of the inverse. Yeah. And then the range of the inverse will be the domain of the original. So you're looking at the x's now. Bella, what's the range of the inverse then? AKA, what is the domain, what x values of the original? Is there any x value it can't be? Yeah, it can't be 1. There's my, same as this one, couldn't be 2. So it's y an element of or, y cannot be 1. You don't need to draw. You can go to the effort of getting the inverse, trying to draw the inverse. It would be messy, but you can do it and then get to the main range. But generally, if you look at the amount of marks given, you know it should be a quicker thing. And the last part then, function h is defined by something and k. So remember, okay, same, you look at the range. All right, and the last part then, we have this h of x function. It's horrible. Square root x minus 1, we have it g. Kx. Kx function, we have x minus 1 squared. And we are asked to state the domain of h after k. Of x. So that's k, so that one has to go into that one. So this one goes in for that x, h after k. So this came first, and it goes in there. X minus 1 squared minus 1. So what used to be the x is now x minus 1 squared. So the domain. Okay, what values can we input? Any value we cannot input? Is everything okay? Clarissa? Maybe, yeah. That's solid, yeah. That's an English answer. Maths has to be more specific than maybe.
0.
0 cannot?
Yeah.
Cannot be 0, why? What's 0 minus 1? Minus 1?
Yeah. And then
minus 1 squared is 1. 1 take away 1 is 0.
square root 3.
I can't, 0. That's allowed. 0 is allowed. It said that original one is bigger than 1, yeah. But it's not necessarily the domain. It's only saying that because this can't be square root of a negative. Yeah, do you know already? Anybody else? Ready? Anything that's going to make us negative. So what's going to make a negative? 2. 2 minus 1. 1. 1 squared. 1. 1 minus 1, 0.
Everything.
Everything.
Yeah.
What about a number that gives less than 1 here? Yeah. What about 1.5? 1.5, that's 3 over 2. 1.5 take away 1 is a half. Half squared is a quarter. Quarter take away 1 is negative. It's negative 3/4. That's not allowed. Anything above 0?
A whole number.
Everything? No, it's besides a half. But we can have an 1/8, 2/3. Any fraction's not going to work. Any positive fraction's not going to work. Is a negative fraction okay? Minus a half. Minus a half minus 1 is minus 1.5. Minus 1.5 squared is going to be bigger than 1, isn't it? Be like 2.25 or something. That's going to be bigger than 1. So minus negative fractions, okay. And it could be 0. Just can't be fractions. Can it be 1? 1 minus 1 is 0. 0 squared is 0. 0 take away 1. That's no good. Can't be 1 either. Okay, can it be 1.5? We used that one already. 3 over 2. 3 over 2. Half. No, it can't be 1.5. Can't be a half. Can't be 1.5.
Everything less than 0.
Yeah. Can be negatives. Anybody want to suggest what it might be? Can it be 2? 2 minus 1 is 1. 1 squared. Okay, can be 2. Can it be before 2? 1 3/4. Anything less than 2? Can it, and 0 is 0, okay? It cannot be between 0 and 2. That's it is. So x has to be less than 0. And x has to be greater than 2. Can't be 0. Can it be 0?
Yeah, yes.
Can it be 2? 2 minus 1 is 1. 1 squared is 1 minus, yes. Okay, so it would be greater than equal to. Yeah. That's what you'd have to do. It's worth 4 marks, isn't it? So it's supposed to be difficult. That's at the end of the question. All right. As long as it makes sense. Just trial. If you're unsure about domains, trial your numbers. And you know that square roots can't be negative, so keep trying. Just make sure you found the point where it switches. Okay, so that was that one. Nora sent me a few that she couldn't do, or she had problems with, so maybe we'll look at those. Anybody else have problems with any particular problems? Anybody else knew how to do everything? This is the mark scheme, actually. I want to show you this briefly. You can see that. I don't know if it's much of interest to you. Oh yeah, I want to show you how to. So this is the first one, just where in a temp mark, any sort of rearrangement of the numerator will get you a temp mark, which is nice. So maybe some of you did that when you did that. This is the new method we know at the moment. We will know that by the time the exam comes. Yeah, that's fine. You get it right or wrong. It's interesting that the temp marks, you need to have an asymptote. You need to have your axis intercept, so those roots, and you would need to have the correct shape or branches of the hyperbola. That's the name of the shape in correct quadrants. So just in the correct top left, bottom right Yes, full marks. That's just interesting aside. And did we get that one right? Yes. Okay. Got that one right. Okay, and that's there was no real attempt marks, was there, for that? Attempt to form. Oh, you did get attempt marks if you just did this. So you got 2 of the marks if you managed to do that, and 1 mark each plus 2. Okay. Laura was asking me about limits to infinity functions, which obviously the rest of you know really well, but I'll go through it anyway. Laura has a comment. 1. Not sure what that referred to, Laura, but yes. Okay. So these are taken from the revision practice questions. So the answers are there already. G after f, we probably should be able to do, and then given that the limit goes, okay. So G after f of x should be able to do. I think this was like question 10 or something from the revision. Oh yeah, could not be 1. Oh, thanks a lot. Yeah, you're right. So f of x was e x squared, so that needs to go into the 3. So 3 times e to the x minus 2 plus some k. That is g after f of x. Hopefully you're able to do that. You can multiply that out. 3 e to the x minus 6 plus k. Hopefully that's right. And the second part then, given that the limit to negative infinity, waiting for someone to maybe explain this then. Limit, as this approaches negative infinity, equals negative 4, find the value of k. Anybody know what to do? No? Ella? Cry a little bit, yeah? Yeah. So,
Can you substitute
yep, negative infinity. Yeah, this is a little bit different. Okay, so this is talking about, okay, as this function goes on and on and on and on forever, what does it look like? Where is it going? The nature of this function is it flattens out. You did this, Mr. Kidder, say? Did you? Yes, e to the x, what does it look like? What does e to the x look like? Matthew?
Not remember.
Do you not remember? Can anyone enlighten him? The function, not e itself. What does it look like if I were to graph it? Yeah? Jenny? Can't remember? Yeah, it was. What is e to, no, you don't know. None of you know the graph of e to the x. Yes, you do know. Exponential growth. The graph of e to the x looks a bit like that. Something like that. You've never seen that? Oh. All right. Well, that's e to the x. General graph. You can check it out in your calculator. Okay. So it says that as this thing, the other part of this is the e to the x bit, goes towards negative infinity, as it gets really, really tiny, this whole thing goes towards a single number. Okay. This is the function in general. This is not this function. This function has been transformed a little bit. But this refers to the e to the x. So as e to the x, this goes towards infinity. As x goes towards negative infinity, that's this way. What's it tending towards? What value? Output value. So the input is negative infinity. What's the y value? What's the y answer? Yeah, it's getting closer and closer to 0. never actually reach 0, but for all purposes, it's going to be 0.1 billion zeros and 1 or whatever. So it's getting towards 0. So I've looked at what the shape of the graph is, and I know that then this is going to tend towards 0 at this limit. In other words, we can just say that is 0 as it goes there, from my knowledge of what the graph looks like. And usually with limits for you guys, if they can be found, they are usually 0 for you guys. Because if you can find, otherwise it's going to shoot off to infinity, or if it can be found, it's going to be that asymptote. It's going towards the asymptote. That would be a limit as well. So technically, this 0 is an asymptote, isn't it? It's not going to cross that. So I know then that this is equal to -1. And then I can solve it quite easily for k. Okay. So this, for limits, look at what the graph looks like. This is a non-calculator, so that's why I was saying you need to know what e to the x looks like in order to figure out that that is going towards 0 and no other number is going. That's always, it's getting tiny going that direction. It's getting closer. These lines are getting closer and closer together. Eventually. That's e to the x. Very,
Always gonna go.
it's unless it's transformed in some way. Yeah. This is not what that looks like, because this would be shifted down, etc. But this itself, part as a tens. Okay, we're looking at that. Okay, let's do another one of those, because limits can be slightly confusing. It's just going, if you were to draw this graph for infinity, what's it going to look like? How about limits? We only look at generally at a small section, but this is going to shoot off to positive infinity. This way, it's going to shoot to 0. That's the answers are on it, so I just want to make sure that everything is. I didn't finish the question, but you can. Where k is equal to 2. That was question 10, I think. Question 13 had another one. Find the limit as something approaches positive infinity. Okay. Question 13 is on the screen here. Perhaps we can do this. It seems to be a pretty short question. F of x is equal to 2 and x minus a. Write down the value. Oh, the line x is the vertical asymptote. Okay. What is a? So 1 mark suggests it's an easy question. So that means if I ask you now, you should get it straight away. Yeah, 1. Why is it 1? Yeah, so we want to make that this line is 0. You could try to calculate it. X minus 1, a is 0, and we know that when x is 1, that equals 0 because it's the asymptote. When x is 1, it equals 0, so that means a has to be 1 as well to subtract it to get to 0. So a is 1. So I can just pop that in there for that. The answers to these are already in the mark scheme or the revision. So the graph of that passes through some point. Find the value of oh, I forgot the b. The b here. Find the value of b. Method here, lengthy. Find the value of b. If we have if this goes through this point, definitely. What would I do? Yeah, substitute 0 and 3 in. 0 for x, 3 for y, and we should get b. 3 is equal to 2 over 0 minus 1 plus b. That's going to be minus 2, isn't it, all this? Because that's a minus 1, it's going to make that 2 over minus 1. So minus 2, 5. And minus 2 comes over here, so b is 5. Okay. And then part C, the limit as x approaches infinity of the. So the limit as x approaches positive infinity of this new function we found. 2 over x minus 1 plus 5. All right. So the answer scheme does this. Just says that all this is 0. Can you explain to me why all this is 0? Yep. The answer scheme says that all that is 0. You can check it out here. Is it there? Yeah, it just goes 0. That's it. That was the full explanation. You can see, like, cause. Why is it 0?
Because of the x.
It is because of the x, yeah. All right. As it goes towards infinity, well, as it gets closer to infinity, this is going to be a huge number. X is going to be a huge number. It'll be infinitely large, but you can put in an actual number if you want. That's quite large. Go to zeros, minus 1, plus 5. Okay, so that's going to be 2 over 999,900,000. So it's going to be quite a small number. So small, in fact, that as this gets, the denominator gets bigger and bigger and bigger, it's going to tend towards 0, because the fraction is going to get so small that it won't even matter anymore. It's going to tend towards 0. It's going to be huge. It's going to tend. That's going to tend towards infinity because it's going towards the x is going towards infinity. Well, infinity minus 1, which is still quite a big number. And that therefore it's nothing. It's so small, it's negligible. So it's 0 plus 1. So that part has gone to 0 pretty much. Pretty much. It's not exactly 0 because it's a limit. You basically call it, they say, it's going to go on forever, but it's so useless that we call it the limit of it. It's never actually going to get to 0, but we just say, right, it's 0. It's so small. That makes sense, Laura? Good. All right. So if you see limits, and we could have done this in the last question as well, but it's a little bit more difficult because it was e to the power of minus infinity, and maybe you don't know what that would tend towards. You could have put in a very large number here, and it wasn't a calculator question. If it's calculator, you just put in that, and you can just see it's going to be 0. It's going to give you 0. So it's harder to see what that one looks like. This one, just put in infinity and go, right, that's going to be tiny, so 0. So for limits, put in this number into it, in for x. It's either going to be infinity or 0 you'll get to put in as x goes towards something, usually infinity. So it's either going to tend towards, it's usually going to make it really small or really big. So just substitute it in your head. Okay. All right, let's move along to when it goes to negative. No, you don't substitute in 0. You substitute in infinity. So negative infinity, you put in a really, really large negative number. And in this case, that would be 1 over e to the positive infinity, if you know your rules of indices. This number will then be really, really big on the bottom of the fraction. And once again, that goes towards it. So Laura asked, as it goes towards negative infinity, you just do 0. No, you have to apply just a really large negative number. But for when it's a power like this, you can do this little trick. Your indices, if it's a negative power, it can be 1 over. Does that make sense, Laura? The only time you'd substitute in 0 if the limit is towards 0. It's towards infinity, you got to substitute in infinity. Okay.
Like, so either the number is either 0 or.
Pretty.
You said when you substitute the infinity, you didn't get 0.
Oh, yeah, I'm generalizing. Don't put that in your notes. Your answers are usually 0. Yeah. For you guys, HL is slightly different, but you guys usually goes towards 0. But there are exceptions. Yeah. I can't think about it at the moment. Yeah. Just sub in infinity. That's going to be either a huge number or a tiny number. If it's a tiny number, that's 0. Question 20. There was something wrong with question 20. I can't remember what Laura said was a problem with this. Would we be able to solve this? Should be able to give it a go anyway. What would be your first step in solving this? Someone who didn't just nod. See, what would you do here first? It's the log 2. This is question 20 we're looking at, Laura. Yeah. That didn't sound like you see how the thing was. Just throw in our place. 1 plus log 2. What would you change it to, Clarissa? 2 over 2. Yeah, good start. This 1 is log 2 over 2. Why'd you pick log 2? Because the rest of it's in log 2. So I'm going to change that to log 2 over 2. That. What can I do next, Clarissa? You seem to. No. Okay, panic then. Okay. It's a good start though. What do we do next? Matthew?
Now you just kill all the logs.
Kill all the logs? Not yet. No, almost. Can't have 2 on one side and 1 on the other side. You've got to combine these into 1. Yep. So adding in logs is multiplication. These two. Remember, these are you're dealing with indices. So adding and multiplication are linked in indices. So it's 2 times this, isn't it? 2x. This stays the same. Now you can kill the logs. Want a better term. But this still equals that. I just didn't write it again. X squared minus 2. Oh, I remember Laura's question. The question actually was at the end. 2x minus 2. When I multiply that out. Okay, so now I can solve this quadratic looking thing. Non-calculator, so I'll just bring 2x and minus 2 over. I think that's minus 4, and that's plus 3 is equal to 0. X equals. So I'm going to factorize this. Jenny, what would go here and here? 4 minus 3? No. You have to multiply to give 3. So 3 and 1. And you could solve this using the quadratic formula if you wanted. 3 times 1 gives the 3 at the end, and they need to be both minus to get to something. Minus 4, yes. Okay. So what are my answers? X is 1, and X is 3. Everybody happy with that? What's the answer scheme say? X is only 3. X can't be 1. Why can't it be 1? Well, Well, let's look at the question. Let's just take this part, for example. What's log 2 to the 1 minus 1? So that's log 2, 0. What would that translate to? Why is it impossible?
0, 2.
Exactly. 2 to the power of something we don't know. That would be the answer. You want to put it in the box here. Equals 0. 2 to the power of y equals 0. Find something. 2 to the power of 0 is 1. Remember that. Nothing. Doesn't work. That doesn't happen. So this bit wouldn't happen. An error. This bit then is also going to give an error. 1 squared is 1. Take away 2 plus 1 is 0 as well. So that also would give an error. That means it would say error equals 1 plus error, which is an error. So Laura was asking questions. Do you always have to test your answer with logs? Yeah. Just make sure that it doesn't give you an error. Yeah, you have to test both. Yeah. So I tested 3. You test 3 in your head. You go, okay, let's look at it. Does it give a number? Yes. Okay. Does it give a number? Yes. Yeah. But yeah, you would have to test it. Kind of a trick. They take a mark off you for that, and that's a bit mean if you did all this work and you worked it out and you were happy enough. It is a thing. When there's 2 answers to anything, it's a good idea to test both of them. One of them could be an anomaly. Okay, so that's another one of Laura's questions. Laura also asked something about this one, which of course we'd all be able to do as well. Specifically part 2. Is that a Maria, I'd be able to do it nod, or Maria, I don't know how to do it? Had the same question? Okay. Just saving it for after Friday, were you? Okay. So this is question 22. Non-calculator. Write down the domain and range of this. Oh my goodness. Log A. Where A is greater than 0. Okay, so A is and not 1. Okay. So A is some positive number. No, is it? Okay, what can X be? What input values are allowed? Can X be 0? No, for the same reason it was illegal in the other one. Okay, X cannot be 0. We'll just take a note of that. Can X be less than 0? Why not?
Because you can't get a negative answer. I'm squared.
If you're squaring?
Over there.
Yeah, A is positive. I don't think it can be less than 0. You're not going to get a negative power out, are you? And a negative answer out. You could get a fraction out. Yeah, that's okay. But I don't think your answers are going to be negative. Does that mean X can be anything above 0 then? Be a fraction. Okay. So we're setting with X anything above 0 to be our domain inputs. It can be any positive number. That'll be okay. We'll see her for right in a minute. Can't be 1. A can't be 1.
So that means
Okay, yeah. So it's saying log 1 is not allowed. What's log 1 x in general? What does that look like as a that's the thing? How would it'd be 1 to the power of something is equal to x? 1 to the power of something is always going to be 1. So can x then not be 1? Because it's saying a can't be 1. So it's saying 1. But can something else to the power of something be 1? So something to the power of 0 is 1, can't it? So x can be 1 if it was a different number. Okay. A tricky, very, very difficult domain question. This would be, I would consider this HL level as well, but it was found as a last question on a SL level paper. Okay, and then log part. So we've gone with this. We'll see if we're right in a second. X squared y. It's horrible. 9 log y x squared. All right. Any suggestions here? What I could do? What do they want to do? Find all possible expressions of y as a function of x. Y equals. They want y equals. That's what that means. So we've got an x squareds in amongst y's, in amongst logs. We want to separate it out somehow. We have different bases at the moment. How can we deal with different bases? How can we introduce a new base that's all the same? That's right, change base. Whispered. What base will we change it to? We're going to change it all to x squared. That, if I change it to x squared, not a bad show. This one is going to be log x squared y on the denominator. So remember, you can do that. You can pick any base you want. Let's just look what x squared looks like. X squared all over log x squared y. Hopefully this is not the first time you've come across change of base. It's probably the last log rule you did, but it's important. You pick any base here, and I can do the same on this side. It is useful in a way. X squared y this time, all over log x squared x squared. So what you do is, for change of base, you pick your base. So all those x squareds were what I picked, and then it's y over x squared, and then x squared over y. We don't have time. There is some usefulness to this because this will go to 0 or 1, won't it? That's 1 and that's 1, the same thing. But still, you haven't separated the x's and the y's. You want to separate the x and y, so you got to pick a different base. So if you took that down, it's not wrong, but it is you would get a 10 mark for that because you attempted to change base. I would pick, if you ever have a choice, I would use natural log. And I'll try and do this quick now. So I'm going to do natural log because it's easy to write. And that's log base e, y over ln x squared. It doesn't look as bad already. And that's 9 ln x squared all over ln y. Okay. That 2 can come down, can't it? To actually give 18. See that? And this 2 can come down as well using the algorithm. So already it's looking a little bit nicer. Let's bring the y's up to one side and the x's to the other side. And this is, I think, where the mark scheme does not explain what's happened. So that's going to be actually ln y squared times itself. This is then 36, 2 times 18, ln x squared.
Where did the 2 come from?
The x squared. So it was x squared, and I brought it down in front. And the same here. This was x squared, so I multiplied it here. All right. Okay, and I want just ln. I just want y. So I'm gonna have to square root both sides, get rid of this squared. So square root this side just gives ln y. Square root this side gives 6 ln x, but they both could be plus or minus, so this can be plus or minus. Square root of something can be plus or minus, and that's where the, if I remember correctly, I don't think the Marxism quite explains where the 6 came from and where the plus minus comes from. Yeah. Okay, yeah. All right, and to finish then, well, it's here. Y can be, well, how do you, there's ln's on both sides. So you can, this 6 can go up as plus 6 or minus 6. And this, once again, with the marking, doesn't quite, there's 2 answers. So ln y can be ln x to the minus 6, or ln y can be ln x to the plus 6, from the plus minus. Then the natural logs are cancelled because they're the same on both sides. Y is then in this, thank you, is equal to x squared from this one. And from this one, y is equal to x to the negative 6. Or not x squared, x to the 6. And that's 1 over x to the 6. That's a really difficult question. How do you change it to ln? Is it also the change base? Yes, it was a change base. It's changed to ln. So ln is just a short way of writing log e. You don't know what ln is. It's just a short way of writing log e. And it's just another change base. And down here, they're both log e's, and they can both cancel. That was, I think, was the most difficult log question on the practice, definitely. All right. I presume that's the end of the questions? Yes. Yeah. Okay, if you've logged 7, 16, and you want to change base of 7, 16, you can pick log x, 16 over log x, 7, if you want to pick x. The question will determine what you want to pick. If there's already something in there like log 2 in the question and you want to change this to log 2's, then that would be a 2. If in this case you choose your own, because all the bases are different, pick log e because it's just easier to write. You could pick log 2 and eventually the log 2's would cancel the same here. But I picked just because it's easier to write. Yeah. Now, the questions we did today were on the difficult end. Make sure you can do the easier ones first before you start challenging yourself with the difficult ones. Again, just get caught up. Know the basics first. Okay. Laura, any other questions? Are you good? Let's just. All right. I'll do that with you now. All right. See you. Okay, I'll do that last question. Bye, guys. Okay, so Laura, the last question in the quiz, which was 14. 6x is equal to 64, x plus 3. Okay. And they want ln2 and ln7 in the answer, I think. If you want ln2 and 7 in the answer, it means that you want these bases to be 2 and 7, or 7 and 2, or some form of that. So let's see, can we do that? Well, I know 64 can change into 2 to the power of something. 2 to the power of 6, is it? 2 to the power of 6 to the x plus 3. Right, that can tidy up into 2 to the 6x plus 18. Okay, that's the left-hand side done for now. The right-hand side is a little bit trickier. In general, when we looked at this example yesterday with the class, if you have like 6 to the power of 2, is that the same as 3 times 2 to the power of 2? Can then they be separated into 3 squared times 2 squared? Is that allowed? So the same as I want to split this up into 7 times 2, because I want the 7 and the 2. And let's test. 6 squared is 36. It's split up and then separately squared. That's 9 times 4, which is also 36. So that's a simple example that kind of shows that it does work. So I can say here then 2 times 7 to the 6x, and then separately I can go 2 to the 6x times 7 to the 6x. Okay. And now I see that on both sides of the equation there is a 2 to the 6x. I kind of can unsplit up this one. It's adding up here, so it's multiplying when you unsplit up, because adding and multiplying are directly linked in this form of indices. So I have 2 to the 6x on both sides. And if they're on both sides, I can divide both sides by it. I'm left with this. 7 to the 6x is equal to 2 to the 18. Okay. Now, if I want to get powers down out of the power position into a position that's easier to deal with for us to solve this, because these two bases are not equal, I have to use logs. And once again, I'll multiply both sides by a log so that power can come down. So the natural log is a good one to multiply by. You can pick any one because it'll have the same thing. I haven't changed the equations because we're the same to both sides. Then the 6x can come in front and the 18 can come in front here. 6x ln 7 is equal to 18 ln 2. And now I have an x that I can remove from the 7. So ln, if I divide both sides by ln 7, put it up here, divide both sides by ln 7, I'm left with 6x is equal to 18 ln 2 divided by natural log of 7. And then divide by the 6. So 6 divide. Okay, and then 18 divided by 6. Just the coefficients here is just 3. And 2 over 7. That's the answer. Did that make sense? Any bit you want me to explain? Are there also, did you do the last question on the quiz? Oh, I did that. Are there also answers to the other questions on Managed Back? They are not on Managed Back. I did them yesterday in class. The answers, I can tell you, to the first one was k less than 10 over 3 and k greater than 1/3. It was 2. And that was the first one. And the second question on Managed Back, the answer was k was 2. And then I did the third question today in class. Did you get those?